So this will be the last lecture as we lead up to the topic of hypothesis testing. So if you haven't been following along, the last lecture was on central limit theorem in the playlist, and this is on confidence interval of the mean. And confidence interval of the mean is essentially how confident are we that a population mean can be discerned from observations selected from such, okay? And this will make more sense as we go through this particular series of slides, and we'll do an example or two in RCommander. And as always, the code is in the video description, along with the CSV version of the data that we're going to be utilizing for the examples. So informally, in frequentist statistics, a confidence interval is an interval which is expected to typically contain the parameter being estimated. So let's do it in layman's terms then. In layman's terms, plainly stated, the confidence interval of the mean is the estimated differentiation between a sample's mean and the assumed mean of its corresponding population. So essentially, what is the population mean given a sample from that population? The data sample must be from a population which is assumed to be normally distributed for any of this to work. So if observational data is assumed to be normal, where on a Gaussian distribution curve would a certain observation lie? So again, we're trying to determine what the population is of a particular phenomenon given samples from that population. And we're trying to determine it with a certain confidence. And that's what we're going to do here, okay? So this is our example. And this is how this is typically derived and typically written out. So if you're ever asked to determine the confidence interval of the mean and at a particular level of significance, in this case, 90%, this is what you would do, okay? So we're assuming that the data, the underlying data, is normally distributed. And that will be the instance in most cases, whether it's in the classroom or otherwise, okay? So a new machine is purchased by a pastry shop, which will be utilized to fill the insides of various pastries. A test run is commissioned in which the following proportions of jelly are inserted into each pastry. We are tasked with finding the 90% confidence interval for the mean filling amount from this process. So here are our prior filling observations. All right, those are the observations which we recently measured from the most recent batch of pastries. So at a 90% confidence interval, we're looking between the values of X and Y. So if the data is normally distributed, what two values will we expect to find the mean between given a 90% confidence interval? And remember, this is the population mean, not the sample mean, but the population mean, all right? We're trying to find at 90% confidence, or determine with 90% confidence where the population mean would be if our data is normally distributed and we have samples from that data. And if you're asked to ever do this, assuming a t-distribution, this is how you would achieve that. And you can do this example in RCommander. However, in most instances, you're going to be tasked in real life to find the population mean given the normal distribution. All right. So here's how you would achieve that. And you can use this code again. It's in the video description below. However, I should mention this, and it is also mentioned in the video description. YouTube doesn't allow you to use angle brackets in the video description. So wherever you see a greater than or less than sign, I can't put that in the video description. So the code is not going to be perfect. You're going to have to fix it yourself. Just fix it by looking at what's on the screen here. Everything that is here will be in the video description, but I can't put the the angles in there. Okay, so those are not in there. But in any case, let's take a look at this in R. So we have to create a function in R, and we'll talk about what a function is and how to create one in another lecture at some point outside of this playlist. But in any case, we're going to create this function here, ci underscore z. So we just run this here, and this is going to create our own custom function in R. Now we have to set whatever we'd like the confidence interval to be. And this is going to become important when we start talking about hypothesis testing. But we have to set our confidence interval. So in this case, we're operating with a 90% confidence interval. It was 95%, this would be 95, and you'd have to then run the code again to recreate the function. But in this case, we're just using a 90% confidence interval, so we're just going to run this all here. And now we have a function which will provide us with a 90% confidence interval for a vector which we create and pass into the function. So let's go ahead and create Pastry. So Pastry is our vector, and the elements are our observations, 28, 25, 22, 20, 33, and 20. So let's go ahead, create this vector. As you can see, it was successfully created. And now we're going to use this function, and within the function, we're going to place our data vector. So here is our output, and you can see in this comment here, this was not something that I created myself. This was actually created on an R bloggers entry. So if you wanted to check out the site from which I borrowed this code, go ahead and follow this link. Again, this will also be in the video description. But in any case, we now have the confidence interval lower limit and the confidence interval upper limit. So what does this mean? You're going to need these values here. So you might want to copy and paste these or write them down on a piece of paper because you're going to need to use these values when we're stating our findings. So let's go back to our PowerPoint slides. Here we are. And there we are. So here's what our findings are. Assuming that the population data is normally distributed with 90% confidence, we can state that the population mean is between 0.212 and 0.28, which essentially infers, but don't write this portion down. Assuming that the population data is normally distributed, we can state with 90% confidence that the machine will insert into Pastry's proportions of filling between 0.212 and 0.28. But really, scientifically, this is all that we need to state. This is all that we're stating, all right? Because all that we're doing here is we're trying to determine with a certain level of confidence, in this case, 90% confidence, and this will become clear or clearer as we go through hypothesis testing. We're trying to state with 90% confidence where we might expect to find the population mean with the observations we have. All right, so if you're doing this for a publication or if you're doing this for a classroom exercise, this is how you're going to perform this particular task. And this is how you would do it if you're using R to assist you. Now, if you're in a situation where you're assuming the data is adhering to a t-distribution, and you're not really going to encounter this unless you're informed by your professor or by your research team that this ought to be the case. Normally, when we're talking about confidence interval to mean, the assumption is that the data is normally distributed. We're not assuming a t-distribution. If you are assuming a t-distribution and you are publishing your findings, make sure that you put that the t-distribution was assumed in determining the confidence interval of the mean in your methods section if you do have to determine the confidence interval of the mean. All right, so only do this particular next couple of steps if you're informed that you ought to do such by your methodologist, your research team, or by your classroom professor. Otherwise, in every instance in the outside world, use the method that we had just utilized, where you're assuming that the data is normally distributed, and use the function that we had created by custom within R. All right, so we're going to assume a t-distribution, and we're going to use this data, the Pastry data, that we had collected in our example problem. So what you're going to have to do is you're going to have to import this data into RCommander either as an Excel file or as a CSV file. And if you need help doing that, there is a video which will show you how to do such in the playlist for which this video is currently located within. But once you have this data imported into RCommander, you can follow the appropriate steps and determine the confidence interval of the mean, assuming that the data follows a t-distribution. So let's go ahead and go back to R. And I already have, let me clear this here. I already have our RCommander ready to go. And I've already imported the data. You can see the data here. Okay. And each row observation that is corresponding with a observation from our Pastry example problem. So, okay. Now, we're going to go to statistics. We're going to go to means. And we're going to go to single sample t-test. We're going to select our variable. In this case, it's Pastry. We're going to keep the alternative hypothesis at population mean does not equal mu0. And we have to set the confidence interval to what is appropriate for our problem. So we're assuming a 90% confidence interval. So we have to change this to 0.90. And remember, if it were 95% confidence, this would be 0.95. If it were 99% confidence, it would be 0.99. But in this case, it's 90% confidence. And once we have all of this data, or all of these selections appropriately made as it pertains to the data, we would go ahead and click OK. And here is our output in the R Studio console. And here's the code that was performed by RCommander on our behalf. So this can be difficult to see if you're looking at this on your screen at home. So let me go ahead and go back to the slides. Be sure to set the appropriate confidence interval. So these are our findings, and I'll show you where our findings were derived as it relates to the output. Assuming that the population data adheres to a t-distribution with 90% confidence, and see here it's a t-distribution, before it was a normal distribution. It's important that you state what distribution you're drawing inference from. Again, always it's going to be typically a normal distribution, but in this case, assuming that the population data adheres to a t-distribution with 90% confidence, we can state that the population mean is between 0.205 and 0.289. And this essentially infers, although you wouldn't write this, assuming that the population data adheres to a t-distribution, we could state with 90% confidence that the machine will insert into Pastry's proportions of filling between 0.205 and 0.289. But that's not really what's going on here. This is what you want to report, but you can kind of just, on the back of the napkin, understand that this is what's happening. And where do these two values come from? Well, they come from this portion of the output, which is found within the console of RStudio, from the code which was created and executed by RCommander, the code that we had just created by going through the various steps. So that is it for this particular lecture. I hope that this was able to assist you in whatever your needs may be. If you made it this far, congratulations. And if this helped you out, please consider liking and subscribing. Best of luck with your research and best of luck in your class if you're currently enrolled within one. I hope to see you next time. Take care.